x e to the 2y is equal to e to the x, and we need to prove that it differentiates to this differential equation on the right hand side. This is a product, so let's differentiate then. So differentiating gives, so this is u times the v dx, function of function e to the something differentiates to e to the something, multiplied by the something differentiated, which is 2y dashed. So that's u to v, plus v times du, x differentiates to 1, is equal to, and e to the x differentiates to e to the x. Differentiate again then. The only thing to observe here is that when we do this part of the product, let's call this u, and this part is v. When we differentiate once more, the u dx is already done because it was the thing we did just above here. So we can simply write down these terms here for du dx, can't we? So bearing that thought in mind, let's carry on then. So differentiating, that's u times the v dx, which is 2y double dashed, plus v 2y dashed times du, and this is where we can replace that by all of this. So we've got x e to the 2y times 2y dashed plus e to the 2y, there we go, is equal to, and e to the x differentiates to e to the x. So what have we got then? We've got 2x e to the 2y times y double dashed, and then we've got 2y and 2y, so that's plus 4 x e to the 2y, yeah, times y dash squared plus 2y dashed times e to the 2y is equal to e to the x, which is x e to the 2y. Okay, so let's divide by e to the 2x e to the 2y then, all the way through, and see what we get. Gives. So divide this, we just get y double dashed here, plus 2x leaves 2, y dashed squared, plus, and divide by 2, we just get, oh hang on, y dashed, there's a 4 here somewhere, there's a 2, anything wrong with that? No, that's fine. Oh, hang on, because I did u to v dx plus v du dx, but I didn't differentiate this term here, so I need to put that in here. So let's just make a correction here. So I differentiated this product and wrote down these 4 terms, these constituent parts here for the product differentiation, but I didn't include this here, and this differentiates to e to the 2y differentiates to e to the 2y multiplied by the 2y differentiated, which is 2y dashed, and that goes in there, and it also goes in here, so we got another 2y dashed. As I noticed, this was going to be different from what I wanted to show, so we need to change that to 4. So let's do that then. So it's handy to have the answer already written out so that you can check that you haven't made a mistake, which we've just corrected now. So this, we're divided by 2x, so the 2 will stay there and x will come underneath. The e to the 2y will disappear and we get y dashed. And then we're going to move this back through the equals, which becomes a minus. The x will cancel and the e to the 2y will cancel, but there's still a 2 underneath, isn't there? Minus a half. There we go, and that's what we wanted to show.